Okay, let's look at example 4. These are tricky question, but you can always you can solve it algebraically. You can also solve it using try and error approach. So let's look at the question. The sum of the digits in a two-digit number is 8. If 18 is subtracted from this number, the number's digits are reversed. Which of the following could be the original? So here is a common sense problem. So the sum is 8. So obviously you can start with these are your answers. So the sum is 8. Obviously, then this is wrong, right? Because 3 and 2 cannot be 8. Now let's look at this. So if it's 53, the same when you subtract 18 from that. So let's subtract 18 from this. 18 from 53 is 35. So it's 35, right? 35. Is that true? Yes, it's reversed. So that's probably your answer. Let's try 62. 62 minus 18. What do you have? 62 minus 18 is 44. And so that's not the reverse. 72 minus 18 is um, 53, I think. And that is not the reverse. So that means the only possible answer here is B, right? So you can use this simple logic to do the work. And this is straightforward. But I'm going to take you an interesting route to see if you want to solve this using algebra. So let's assume the number is xy. If it is xy, then we know that x plus y is equal to 8. But this is the trick. When you subtract 18 from the number, but remember, if the number is xy, then the actual value of the number will be 10x plus y, because this will be the 10th digit and this will be the unit digit. So 10x plus y, when you subtract 18 from it, the answer will be equal to yx, which means it's going to be 10y plus x. Do you see that? Yeah, if you don't see this, you can never solve this algebraically. You have to see it this way. So we can simplify this as 10x minus y plus y minus 10y is equal to 18. I'm just moving numbers around. And that means I have 9x minus 9y is equal to 18. You see? And I can still simplify the divide through by 9. This gives me x minus y is equal to 2. Ha! Isn't that interesting? So I have this equation as equation 1. And if I call this equation 2, guess what? When I add the two equations together, I get x and s. I get 2x. These y's will cancel out, and that will be equal to 10. And that gives me x is equal to 5. If s is equal to 5, then I can come back here and say, well, then my y will be equal to 3. Right, and that is why we still have the number as 53. So that is a pretty cool way of solving this problem. I know in an exam environment, you probably want to do the first approach because that is much easier than trying to go through this route. So, but I just want you to know that, these are algebra problems and mathematically they are all solvable.